Welcome to How to Succeed in ECE Without Even Trying. I'm Dr. Linda DeBrunner, and today I'm doing another example of a three-variable K-map, using it to minimize a function. Today I'm using the function f of ABC is equal to the sum of minterms 0, 1, 2, 4, and 5. So our first step is to go ahead and plot this on the K-map. I'm going to label my variables as shown. There are other labels possible, but you would have to adjust where the minterms are to correspond to your labeling. So this is the way I do it. And so now we'll label our minterms. This corresponds to minterm 0, which is A bar, B bar, C bar. Here's minterm 1, A bar, B bar, C. 2's here, A bar, B, C bar. And then 4's over here, A bar, B, B bar, C bar. 5 is here, A, B bar, C. Okay, now we could put zeros in these other locations, but it's understood to be zeros. That just makes it a little harder to see everything on the screen, so I don't usually do that. And the next thing we do is, again, we always look for the minterm that's adjacent to the fewest other minterms. Okay, so we do not look for the biggest group. We look for the minterm that's sitting by itself. So if we go through there real quickly, minterm 2 has 1 adjacency. None of them have 0 adjacencies, right? So that means that we could definitely just start with minterm 2. Now, instead of looking at all the adjacencies before we start, what I like to do is look for any term that's by itself with 0 adjacencies. We don't have that. Then I look for terms that might have 1 adjacency, and I find one. I quit looking at that point in time. It doesn't matter which. If you had 2 with 1 adjacency, it wouldn't matter which one you use. So I just go ahead and take the first one I see, and I go ahead and group it. So if I look at minterm 2, I can see it's adjacent to one other. And I would ask myself, is it in a group of size 8? No. Is it in a group of size 4? No. It's in a group of size 3, right? Like this. But we don't allow groups of size 3. So that doesn't help us. I can't do catty-cornered, right? I can't do those two together. I can't do this group of 3. So really what we're doing is we're just looking for big groups that are squares or rectangles. Okay, so again, is this adjacent to, is it in a group of size 4? No. Is it in a group of size 2? Yes. So let's go ahead and group it with the one next to it. And that corresponds to A bar, C bar. And how did I know that so quickly? I can see that in both these columns, A is 0, and in this top row, C is 0. Okay. Similarly, B changes from one minterm to the other. So I know it's going to be A bar, C bar. Okay, now we need to look at another term. So I look at any of the terms that are not already circled. Remember, you only have to cover each term once. So if I look at this term, I can tell it's adjacent to the term below it, but it's also adjacent to the one around the edge, right? We have an adjacency around there. So I know that this term is adjacent to 2 others, this term and this term. This term is adjacent to 2 others. This term is adjacent to 2 others. So it doesn't matter which of these terms I start with. I'll start with this one. Why not? Ask myself, is it in a group of size 8? That one's pretty obvious. If they're all 1s, you would know that the function is equal to 1. It's not. Is it in a group of size 4? And the answer is yes, it is. And the group of size 4 is going around the edge, okay? And that corresponds to B being a 0, so that is equal to B bar. So we're done. At this point, we don't need to do any other groups. Every term is covered with the biggest possible grouping of power 2. And just a reminder, just because I like to say it pretty often, the K-map is just a way to let us use the combining expression xy or xy bar is equal to x. It's just a graphical technique to make it easier for us to see. Thank you.